Hi everyone. In this video, we will learn about recommender systems. For example, we want to recommend users similar movies or music based on their choices. Recommender systems are very widely used in software industry to enhance the user experience, increase the revenue for many different companies. It provides competitive edge such as attracting and retaining users. We often watch YouTube videos and YouTube is able to recommend us the most similar next video based on our past history. So this is a very critical form of data-driven decision making, which often help companies to do content curation, develop marketing strategies, and user engagement. In software industry, there is a huge demand for people who can design such systems which can scale for millions of users. In this example, we will use a form of collaborative filtering, where we will predict user preferences by analyzing kind of some form of database system. We have data where users have rated the past history, and using that, we would like to recommend similar items. More specifically, in this one, we would like to recommend similar movies. Let me explain this problem more clearly. And here we will use a simple notation to show what is going to happen. For example, we have a set of users. These are the set of users. And we know that they have been interacting with certain items. In this case, these are movies. Say user 1 has rated I1, I2, I3 movies differently. Similarly, user 2 has rated M1, M2, M3 movies. And user N has rated P1, P2, P3 movies. So each of these users have a list of movies which they have rated. These movies list need not to be same. For example, for U1, we may have 10 ratings, and for user 2, we may have 15 ratings, and so on. This is very similar to how Netflix recommend us movies. For example, user N is me. I'm a new user. I have watched a few movies, and now Netflix is recommending me the next movie. Based on many different parameters, it will generate a recommendation. How it is going to do that? There are many different approaches to realize such a system. Here we will look at approach where we'll find what other movies are similar to what I have watched. And from that list, we'll pull in that maybe it makes more sense to watch these movies next. Hence, we need some notion of similarity to be defined. And based on these similarities, we will pull in the most similar movies for us to watch next. This is what we are going to develop in this video. And we will see a working example. To develop such a system, we will depend on scikit-learn surprise library. If you have not installed it, you can uncomment this line and install this library. Here, what I'm using is a Jupyter notebook, which is running in Google Colab, and I will share this notebook as a link to this video. We are going to use movie lens dataset. It's a medium-sized dataset where each entry represents a user rating for a specific movie. Let us run this and look at the dataset. This dataset has, for example, user IDs. There are many different users. It has item IDs. Then there are ratings for each of these movies, and some timestamp is also attached. Overall, if you run this cell next, you will see this dataset have around 100K rows. We can also look at, say, how many users it has. Let me say, find the number of users it has. And we want to create a set, so unique ones. And let us say, get the length of this. And you will see that it's around 943 unique users. Now, if we want to say also find out how many movies it has in total, and let us look at the item IDs. And it has around 1600 movies in total and 943 users. So roughly per user, we may have more than one movies in general. Based on the ratings of these items, we'll try to find similarities. Let us visualize the ratings as such we have here. We have around 5 different rating scale available. Most of the movies have rating of 4, then the movies which are low rated, the movies which are fairly high rated. And here we see the count of each of them in this distribution, which we are showing. The approach we are going to use is collaborative filtering. It is a method which is used to recommend items like movies to users based on their preferences. We are going to use a technique called KNN, K nearest neighbors, for collaborative filtering. KNN technique is very widely used. K nearest neighbor is a general purpose machine learning classifier, where K stands for how many nearest neighbors we want to find based on some similarity metric. For example, I'm more interested in movies which have action items, and I'm interested to find 10 most similar action item movies. Main idea here is the similarity calculation. That is the heart of this problem. And the better similarity calculation is, the better our recommendation system are. So we have to define a notion of similarity. In this specific example, we will use a notion of cosine similarity, which will find similarity between items and movies in this case based on how users have rated them. Our assumption is the similar movies are rated in a similar fashion. And this assumption, again, is based on how we understand the data. In some data sets, in some problem scenarios, this assumption holds true, whereas in other problem scenarios, we might have to rethink this assumption. So it's kind of cosine similarity. We can think of it as a way to find angle between two vectors, which can represent the ratings of the two items. Again, this basic method can be generalized based user-based similarity or item-based. In this one, we will be using item-based, which means that model looks how similar items are to each other, and it's not trying to find how similar user are to each other. For example, based on the item similarity itself and based on the user's past history of certain items, we will recommend the items for that user based on that. We could have done it the other way around. We could have found the most similar users and then recommended the user items which are used by similar users. So now you can see that this problem can be solved in many different ways. Specifically, we will use an item-based. The k nearest neighbor classifier, like earlier specified, k stands for the number of nearest neighbor we want to consider. So we want to find k most similar items in here, or k most similar movies in here based on user ratings. At the prediction time, what is going to happen? Once we have identified the similar items, the model will predict how a user might rate an item based on the ratings of those similar items. For example, if an item is an action item and it's surrounded by all other similar items which are rated 5, we will predict that this item is most likely also to be rated 5, and so on. Or more specifically, if a user likes movie A, B, and C, and movie A and B are similar to movie D, then we will say that a user might also like movie D. So to note here is that cosine similarity is crucial for determining the likeness or similarity between the items. Let us define the reader and the data set in the notion of surprise. We are going to use user ID, item ID, and rating features from the above data from which we loaded. In the sim options, like we said, it's not a user-based item-based thing, and we are going to define a cosine similarity-based system. Let us define the model. Now, in like many of the crucial ML models, we are often interested to see how good the model can be generalized. One of the way to do is to do cross-validation, that we will pass this cross-validation function, the model, the data set, what are the measures we are interested in, and how many cross-validation split has to create. Here, CV is equal to 3 is like it will train 3 different models in a different form of split and show us what the model metrics look like. Let us run it. It's training the first model. It's almost kind of done. They had to create cosine similarity metrics internally between measuring how 2 items are related to each other. In the future videos, I'll try to show how this cosine similarity metrics look like. In this one, we are going to use kind of inbuilt library functionality, which is often most of the data scientists true. But to note that you need to understand these basics if anything gets wrong in the system, so you can debug it easily. Like I said, we have created 3 different folds. So these models we are trained. RMS is roughly 1. MA is across these 3 different fold is roughly 0.82 or so. So model is kind of reasonable. It generalizes the data set is actually good data set. Also shows us the fit time, test time numbers, and test RMS, MA as well. And as you see across these 3 different folds, it looks reasonable. Now let us train a model. It's also very subjective. These MA, RMSE numbers are not going to tell us how good or bad the recommendations are. So those recommendation quality often has to be ranked through many different tests. In this one, we are going to use the entire data set to train a model. The cross-validation is just to show the generalizability across different splits. Now, once the data set is used to train the model, let us find similar items for user IDs. So we have, like we saw earlier, around 900 or so users. Let us find a similar item for first user. What we are doing here is we're taking items it has rated. We want to make sure that the unrated items are the one from which we find. So already the item who are already rated for this user has already watched those movies. User is not interested in them. And for the unrated items, we'll estimate their rating. Unrated items estimate their rating using the predict function of the model. Given a user ID, and for a particular item, it will estimate the ratings. And we want to find the top recommended items for the user. And as you see, the estimator rating, the highest, we want to recommend that items to this user specifically. And let's look at the top and recommended items for this user. It will take a few seconds for us to run, but you can, like here, we are finding 10 top recommended items. We're taking the top 10. You can find as many recommended items as you want. Takes a few seconds to run it. Like for example, it has found all these item IDs, which are mostly highly recommended for this particular user, and so on. And now many times the values may be copied and so on, because maybe in that user range, there are no other similar items or ranked for us to find. Like you see here, we are developing similarity and KNN clusters, but K nearest neighbor may not be able to find that many nearest neighbor as we are interested in. Another item for user 2, and we are able to find several different highly ranked items here. This completes this tutorial. In summary, we looked at a recommender system. We saw a simple example using collaborative filtering. In today's world, this example is too simplistic, but this is a very good starting point. We can improve the similarity metrics to make better and better recommender systems. I'll see you in next video.